This is lab number 1 and 2. So lab number 1.
Wait, do number 2 first.
No, you just do /T.
Do number 2 first. Oh, okay.
Yeah, because I want to at least attempt.
Just close your ears.
Just act like normal, dude.
All right, I think everyone should know how to do lab number 1. I'm not even going to go over lab number 1 because it's pretty much just changes to be 10. And all right, so lab number 2, nice and pretty little square of stars here. All right. So lab number 2, I was asking for printed so it outputs a square of 100 stars. How do you do that? Because 10 times 10 is 100, right? There's 100 stars, yay. All right, print out 2 rows of 50 stars each. This is rows, this is columns. So I want 2 rows of 50 stars each. Okay. And then 2 columns of 20 stars each. Like that. All right, how about one more? How would I have this thing print out like a staircase of stars? I wouldn't need coordinates. The staircase of stars.
Wouldn't you have to do an offset for rows, like a space for the rows?
So yeah, let's have it print out 10 rows of a staircase of stars. How does that work?
You have to use like space or tab or something, right? And have it put in like a space, a certain amount of space for the first one, a certain amount of space for the second one.
You could. So it's actually very simple. It's like it's almost exactly the amount of stuff that we have to change to make it row print out 10 columns. So the tricky part is that. What does this mean when we use the variable I here, right? This says print out however many columns that's told by J. And J, the number of columns here, is determined by the number of rows that I specify, right?
I want each column, each row. Gotcha.
Right. So this is 10 rows. We know that. This says print 10 rows of stars. Cool. This says print some number of columns. The number of columns here is determined by the row I'm on plus 1. So the first one's going to be starting at row 0 plus 1. So it's going to print out 1 column of stars. The second time through the loop, it's going to print out whatever row I'm on plus 1. So it's going to be 2. It keeps going over and over again. Okay. So we know that this thing is handling rows and this thing's handling columns. So if we just use the number of rows that we're on instead here, we can print that out.
Can you show us the other way?
You mean the reverse staircase?
Yep.
Like long one?
Mm-hmm.
So it starts at 10 and subtracts 1?
Mm-hmm.
So what does this do?
Dude, Rob, this is our last star.
I'm missing a star. Oh shit. Did I add in the 1, 2, 3, 4, 5, 1, 2, 3, 4, 5? Oops. It's because, in this case here, because we start at 10, we could just do this. So by using the intervariable, you can also change how this thing prints out. How would I have it print out a descending staircase and then an ascending staircase afterwards?
Next to loop.
Well, could do that. Just copy that loop and do it over again.
What if you gotta do it without copying the loop?
That means I need 20 rows, right?
Yeah.
That means you need an if statement. You still need a way to basically count between those two. Oh wait, this is not going to work either. All right, so this lab can go a lot of different ways. Understanding how loops work and how those variables work within inside a loop are going to help you work with them a little bit cleaner. All right. So let's do a little bit more with that with lab number 3. So lab number 3, which I'll put up right now. And please do not edit this one. Do not double click on that file. Who did it?
Who did it?
Who did it? Who double clicked on that file? All right, so let me show you guys what this is. This is a program, the little program I wrote like many years ago for this class. And it is a simple RPG fight simulator. And the idea here is that you're fighting a monster that has 100 HP, and you have 100 HP as well. And you pick one of 3 attacks. And the monster randomly switches his resistance every round. So he becomes resistant to either physical, magic, or ranged. If he's resistant to your attack, he takes no damage. He's always dealing damage to you, though. Okay? And your goal is to beat him before he beats you. You do more damage than the monster does, so you have a little bit of an advantage there. So the idea is that I pick an attack like physical. And I hit the monster, he has 88 health. The monster hits me, and I have 90 health. And if I just pick physical again, I eventually will hit an immunity. So the monster has an immunity, he takes no damage that round, and then he still deals damage to me. Okay? So this program runs until one of us dies. So the monster has -9 health, so I won. That's cool. And this is kind of using everything that we've learned up to this point to simulate a situation where you want to actually have a fight happen. Okay. So let's go over the details of it. It's not actually that much more different than anything we've actually done before. But I do have a little bit of error checking here. Like if I try to type in 6 or 0 or something like that, anything that's a number, it'll tell me I have to pick an actual valid choice. And I have these variables up here which control monster and player health. So the general idea of this is that you loop until either you have less than 0 health, less than or equal to 0 health, or the monster has less than or equal to 0 health. And every time you go through that loop, you have the monster pick a number. Between 1 and 4. Sometimes he won't have an immunity at all. So we're rolling a dice, pick a number between 1 and 4. We say if it's one of those 3, then we print out that he has an immunity. That's his monster choice. If his choice is not equal to your choice, which means his immunity is not the weapon attack that you chose, you will deal damage. Okay? Is rolling a dice again between 10 and 21 damage. Otherwise, he will laugh at your face. Afterwards, he figures out how much damage he deals to you by rolling another dice between 5 and 11. Okay? And depending on what happens, you keep looping as long as both of your healths are greater than 0. So you will keep doing this fight as long as both of you are still alive. And then at the end, whichever one of you guys has 0 health wins. Or loses. The other guy will win. So, for example, if I change my health to be like 10, just to force myself to lose this fight, totally unfair, I immediately lose in that case, even though I hurt the monster. Okay. So what I want you guys to do is lab number 3. I want you to change it so you have a 50% chance of getting hit instead of always getting hit. That's the first piece. Right now, you are always getting hit. So 50% of the time, you should be able to basically dodge the monster's attack. Number 2, I want you to be able to ask for the player's level. So the very first thing you should do is, hey, what level do you want to be? The health will also scale with his level, and then the damage will also scale with the level. So the player's level will be added to the damage. And then finally, I want you to add a 4th attack called Sacrifice. This one will always hit no matter what the monster rolls. It means that the monster cannot be immune to it. However, you lose 10 health every time you use it. Okay? So the first one is figure out where in the program you're taking damage and roll some dice, just like how we're rolling dice for damage, and write an if statement that says you dodged it. How do you get a dice that rolls 50% of the time? A 2-sided dice, a coin that you flip. So if you roll a number between 0 and 1, that's a 2-sided dice. That's a coin flip. That's a 50% chance to get one or the other. So now that you know that a number between 0 and 1 can give you a coin flip, you can write an if statement that says, hey, if it's equal to one of those, consider it dodged. All right? So do number 1 here in the lab. If you guys are lost, let me know, and I can come around and I can help you. Just find out where you're taking damage first, and that's where you're going to write the first part of this lab.